The seismographs never stop. Throughout October, instruments across southern Italy logged earthquake after earthquake, until the monthly count crossed 1,050 events. The ground beneath Pozzuoli has risen 2.5 centimeters in the past month. Deep below the cobblestone streets and ancient Roman ruins, something is stirring. At Solfatara crater, fumarole temperatures have spiked to 173 degrees Celsius during recent sampling campaigns, among the highest readings recorded in years. Scientists at Italy's National Institute of Geophysics and Volcanology know what these numbers mean. They've seen this pattern before, during the crisis of 1982 to 1984, when the ground rose 9 centimeters per month and more than 1,300 earthquakes shook the caldera in a single month. But this time, the mathematics are different. This time, the relationship between uplift and seismicity isn't linear anymore. It's exponential. The Campi Flegrei caldera sits 20 kilometers west of Naples, a 13-kilometer-wide volcanic complex that last erupted in 1538. For most people, it's invisible. No smoking cone dominates the skyline, no lava lakes glow in the night. Yet, beneath this deceptively calm landscape lies one of the world's most dangerous volcanic systems, a supervolcano capable of eruptions that can reshape continents. And right now, while you're watching this, it's accelerating into territory scientists have never fully documented before.
The latest bulletin from INGV's Vesuvius Observatory confirms what residents already feel in their bones. The uplift rate has jumped from 1.5 centimeters per month in early October to 2.5 centimeters by mid-November. That's an increase of nearly 70% in just weeks. At the RITE GPS station in Rione Terra, the heart of Pozzuoli's historic center, the ground has climbed 155 centimeters since the current unrest began in 2005. Of that staggering total, 18 centimeters accumulated in 2024 alone. The pace is relentless. Every day, the Earth rises another fraction of a millimeter, pushing buildings upward, stressing foundations, opening cracks in walls that families have called home for generations. The seismicity mirrors this acceleration. October saw approximately 1,050 earthquakes ripple through the caldera, most clustered in the Pozzuoli Solfatara Pisciarelli area at depths between 2 and 3 kilometers. These aren't distant rumblings. They're shallow, violent, felt events that rattle windows and nerves in equal measure. But it's the heat that tells the deeper story. At Solfatara crater, the Bocca Grande fumarole, which has released volcanic gases for more than 2,000 years, now exhales at temperatures approaching 173 degrees Celsius. Weekly averages hover around 166 degrees, with spikes during monthly sampling campaigns pushing even higher. This isn't just hot air. It's a thermometer reading the condition of the hydrothermal system 2 to 3 kilometers below, where superheated water and volcanic gases are accumulating under pressure. The temperature at the fumarole is only the surface manifestation. Deeper down, the hydrothermal system reaches 350 degrees Celsius, hot enough to fracture rock, mobilize ancient mineral deposits, and drive the relentless expansion that lifts the ground above. Carbon dioxide floods out of Solfatara and Pisciarelli at rates approaching 5,000 tons per day. This isn't the gradual seepage of a dormant system. It's the signature of a volcano in accelerating unrest, one that's injecting magmatic fluids into its shallow hydrothermal reservoir at increasing rates. Studies comparing recent gas emissions to those from the early 2000s show the CO2 flux from Pisciarelli alone has more than tripled since 2012, climbing from around 200 tons per day to over 600 tons per day by 2019, and continuing to climb. The gas doesn't just vent into empty sky. Being heavier than air, CO2 can accumulate in certain low-lying areas, basements, and poorly ventilated spaces, creating potential hazards that authorities monitor closely. In enclosed environments with inadequate ventilation, concentrations can reach dangerous levels, which is why air quality monitoring remains a constant priority across the caldera. The hydrothermal system beneath Campi Flegrei is both a buffer and a weapon. It absorbs heat from rising magmatic gases, distributing thermal energy through a network of fractures, conduits, and porous rock layers.
As long as the system can accommodate the incoming fluids, the caldera remains in a state of unrest rather than eruption. But there is a limit. When pressure exceeds the mechanical strength of the rock above, something has to give. That's when earthquakes spike. That's when fumarole temperatures climb. That's when the ground rises faster. Scientists analyzing data from 2000 to 2024 have identified an exponential relationship between uplift and seismicity, a departure from the linear patterns observed during the 1982 to 1984 crisis. This exponential trend, according to researchers at INGV, suggests progressive deterioration of the crust's mechanical properties, as if the rock itself is weakening under repeated stress cycles. Each earthquake releases strain, but the data implies it also fractures more rock, creating pathways for fluids to migrate, which in turn drives more uplift, triggering more quakes. It's a feedback loop, and it's accelerating. The 1982 to 1984 Brady seismic crisis offers both a reference point and a warning. Between those years, the ground at Pozzuoli rose 1.8 meters. Thousands of earthquakes shook the area, with more than 1,300 events recorded in peak months, including swarms of hundreds of tremors in a matter of hours. Buildings crumbled, entire neighborhoods were evacuated. The population lived in constant fear that the next tremor would herald an eruption. Yet no eruption came. Instead, the caldera subsided, entering a long phase of relative quiet that lasted until 2005. The current unrest shares some features with that earlier crisis: uplift, intense seismicity, heating of the hydrothermal system, but the mathematics have changed. Where the 1982 to 1984 relationship between uplift and earthquakes was linear, the current one is exponential. This means that for every additional centimeter the ground rises, the probability of seismicity increases not by a fixed amount, but by a compounding factor. And the scientists who study Campi Flegrei are watching those numbers with growing concern. An M4 to M5 earthquake is not a distant possibility. It's a plausible scenario that emergency planners have already incorporated into their risk assessments. In May 2024, a magnitude 4.4 earthquake struck near Solfatara, the largest recorded since the current unrest began in 2005. Earlier in 2025, the region experienced additional strong earthquakes, underscoring that this level of seismicity has become the new baseline. These are not trivial tremors. At depths of 2 to 3 kilometers, their energy reaches the surface with brutal efficiency. Ground acceleration data from the May 2024 event suggests that many older buildings, structures built decades or even centuries ago without modern seismic codes, experienced forces beyond their design limits. Studies analyzing the fault zones activated during the 2014 to 2024 unrest suggest they could accommodate ruptures up to magnitude 5.1. Such an earthquake, if it occurred at shallow depth beneath Pozzuoli or Naples, could cause significant structural damage, potential casualties, and widespread panic in a region already on edge. The vulnerability of the building stock amplifies the risk. Campi Flegrei sits in one of the most densely populated volcanic regions on Earth. Approximately 500,000 people live within the red zone, the area designated for immediate evacuation in the event of an eruption. Another 800,000 reside in the yellow zone, areas at risk from volcanic ashfall. Many of the buildings are old, constructed with unreinforced masonry, designed for an era when seismic engineering was rudimentary at best. Even moderate earthquakes can topple walls, collapse roofs, trap families inside crumbling homes. The Italian government has allocated over 500 million euros for seismic retrofitting and emergency preparedness, but the scale of the challenge is immense. Reinforcing every vulnerable structure, training every resident, ensuring every evacuation route remains passable. It's a race against a volcano that sets its own timeline. What makes the current seismicity particularly unsettling is the emergence of burst-like swarms. These are sequences of earthquakes with inter-event times so short, often just seconds apart, that individual tremors blur together on seismograms. Traditional swarms show earthquakes clustered in time, but with recognizable gaps between events. Burst-like swarms compress those gaps until the ground shakes almost continuously, a phenomenon that has become increasingly common since 2021.
Research published in early 2025 links these swarms to a geodetic anomaly, a region around Monte Olibano that uplifts less rapidly than surrounding areas. This differential deformation, combined with the pressurization of the hydrothermal system, appears to create conditions where stress accumulates unevenly, fracturing rock in rapid succession. At other volcanoes, burst-like swarms have preceded phreatic explosions, steam-driven blasts that can occur without warning. The pattern at Campi Flegrei suggests the crust is under extreme duress, though what this means for the volcano's near-term evolution remains an open question among volcanologists. Naples, Italy's third-largest city, sprawls across the caldera's eastern edge. Over 900,000 people call it home, many living in neighborhoods that fall within the yellow zone. The city is a marvel of history, art, and resilience, but it's also a city built on volcanic soil, surrounded by active volcanoes. Vesuvius looms to the east, dormant but not extinct. Campi Flegrei stretches to the west, restless and unpredictable. In September 2024, Naples City Council approved an updated evacuation plan for the red zone, outlining procedures to move 286,000 residents out of harm's way within 72 hours if the volcano escalates to red alert. The plan envisions a pre-alarm phase, potentially lasting months or years, during which people can evacuate voluntarily, followed by a mandatory evacuation phase triggered by clear signs of imminent eruption. Drills have been conducted, meeting points designated, twin regions across Italy identified to host evacuees. Yet as emergency planners acknowledge, the plan rests on assumptions that seismic precursors will be unambiguous, that roads and railways will remain functional, that hundreds of thousands of people will move in an orderly fashion under circumstances designed to provoke chaos. Whether these assumptions hold in a real crisis remains untested. The psychological toll of living above a restless caldera is harder to quantify. Residents of Pozzuoli describe nights spent awake, listening for the next tremor, watching cracks spread across ceilings, wondering if this earthquake will be the one that brings the walls down. Schools conduct evacuation drills regularly. Children grow up knowing that the ground beneath their playground is not as stable as it seems. Some families have left, relocating to regions farther from the volcano, sacrificing homes and livelihoods for peace of mind. Others stay, bound by economics, by family, by a stubborn refusal to be driven out by fear. The government has discussed offering relocation assistance, but for many, there's no equivalent to the life they've built in the shadow of Campi Flegrei, no place that feels like home. Scientists monitor an array of parameters, each offering a piece of the puzzle. GPS stations track ground deformation with millimeter precision, revealing not just uplift, but also horizontal movements, tilt, and strain. Seismometers record every tremor, from magnitude 0.0 micro-earthquakes to felt events that shake buildings. Gas sensors measure carbon dioxide, sulfur dioxide, and other volcanic gases, tracking changes in composition and flux. Temperature probes embedded in fumaroles log thermal variations every few minutes. Satellite radar interferometry provides wide-area deformation maps, updated every few days. Together, these instruments create a near-real-time portrait of the volcano's state. What scientists look for are changes, rapid increases in uplift rate, swarms that migrate toward the surface, spikes in gas emissions, new vents opening, anomalies that might indicate the system is transitioning from hydrothermal unrest to magmatic intrusion. So far, official INGV assessments point to a pressurizing hydrothermal system, but not to imminent eruption. The distinction is critical, but also precarious. Based on what we've observed at other calderas worldwide, hydrothermal systems can shift rapidly, and the line between unrest and eruption can be crossed in days or even hours.
For those living in the red and yellow zones, preparation is not optional. Emergency kits should include essentials, water, non-perishable food, first aid supplies, flashlights, batteries, copies of important documents. Know your evacuation routes. Identify the nearest meeting points. Keep your vehicle fueled. Have a plan for pets. Stay informed through official channels, INGV bulletins, civil protection alerts, local authorities. Avoid relying on social media for critical information. Rumors spread faster than facts during crises. If an evacuation order is issued, follow it. The time between red alert and eruption may be measured in days, but it could also be measured in hours. There won't be time to second guess.
The May 2024 earthquake caused building damage, but fortunately no casualties. That outcome may not repeat if a stronger event strikes a more densely populated area. Predicting volcanic eruptions remains one of the most difficult challenges in Earth science. Volcanoes don't operate on fixed schedules. They respond to complex, interconnected processes: magma movement, gas exsolution, hydrothermal circulation, tectonic stress, each with its own timescales and thresholds. At Campi Flegrei, the current unrest could continue for years, even decades, without culminating in an eruption. The caldera has experienced multiple bradyseismic episodes in recorded history, including major crises in the 1950s, 1970s, and 1980s, none of which led to eruption. The last confirmed eruption occurred in 1538, when Monte Nuovo formed after months of intense ground uplift and seismicity. That precedent offers both reassurance and warning. Eruptions here are rare, but they do happen. Alternatively, conditions could escalate rapidly: a sudden injection of fresh magma into the shallow crust, a catastrophic failure of the hydrothermal seal, a large earthquake that fractures the caprock. Any of these could shift the volcano from unrest to eruption in a matter of days. Scientists can identify trends, calculate probabilities, issue warnings based on the best available data, but certainty remains elusive, and the margin for error is measured in lives. Every evening, as the sun sets over the Bay of Naples, the city glows against the darkening sky. Tourists walk the streets, sampling pizza, admiring Baroque churches, unaware or unconcerned that beneath their feet the earth is rising. Residents return home from work, checking news feeds for the latest seismic updates, feeling the low rumble of distant quakes. Scientists at Vesuvius Observatory review the day's data, searching for patterns, anomalies, signals that might hint at what comes next. The caldera breathes, the ground rises, the tremors continue, and the world watches, aware that Campi Flegrei is not just a geological curiosity, but a ticking clock, one that measures time in centimeters, in degrees Celsius, and the count of earthquakes that refuse to stop. For 500,000 people, this is not an abstract threat. It's the ground they walk on, the air they breathe, the uncertain future they navigate every day. And as the data from October confirms, that ground is moving faster than it has in decades. If this story of a restless caldera and the people who live above it left you thinking differently about the ground beneath your feet, subscribe. Stay informed, because the earth never stops moving, and neither should our vigilance.